Hey everyone, welcome back to part 2. Okay, so this last question, D, on example 3, first thing you want to deal with there is not to change it to a root, but to get rid of the negative exponent thing. So we're going to move that 16 down to the denominator, so it becomes 1 over 16 now to the positive 1/2. Okay, and by the way, never flip the exponent, ever, okay? If you somehow have gotten it into your head that you just flip it, you never touch the exponent that way, okay? What you do is when you move the whole base of your power to the denominator, that's when the exponent goes positive. It doesn't flip, okay? All right, so then we have 16 to the 1/2, which becomes the square root, right? The 2's on the bottom, so it's a square root of 16, and square root of 16 is 4, so we have 1 over 4. All right, hopefully you got that right. Now, example 4, we're looking at basically changing expressions into a different base. So changing a power into a different base. And that's going to be very important for our next lesson, which is working with exponential equations, where we have to change the base. So this is kind of a warm-up, I guess. So when it says base 3, they're referring to this, which is now a base 9. We want it to be a 3. Okay, so it's good to know kind of your powers, like what is 2 squared, 2 to the 3, 2 to the exponent of 4, 2 to the exponent of 5, all those things. In particular on this one, 9 we know is 3 to the exponent of 2. So what we're doing here is we're just simply replacing 9, okay, and the 2x exponent is still on the outside of this. So we've replaced 9 with 3 squared. So we haven't changed the value of anything. We've just substituted out something that looks a little different than that. All right, so now we're using power of a power rule. So we're going to multiply our exponents, and that would become 3 to the 4x. All right, and that would be written as base 3. All right, let's look at the next one. 125 to the 2 minus x, and we want base 5. Okay, so 125 is going to get scooped out. Okay, and we're going to put in 5 to the, what do you think? Exponent 3? Yep, you're right. Now that 2 minus x is on the outside, but you know what? I want to put brackets around it. And do you know why? Because I want to emphasize the fact that this 3, when we do power of a power, is going to get multiplied or distributed to both terms. So we have to make sure we do that. That's going to be 5 to the 3 times 2, 6, minus 3 times negative x, negative 3x. A lot of people forget that second term. All right, so C, we've got 8 times 16 to the x, and they want base 2. So each one of these factors we're going to change into base 2, and then we're going to use our product law for exponents. So we have 8, which is 2 cubed, times 16, which could be 2 to the exponent of 4, but we still have that x there, so I'm going to keep the x. Now, before we use multiplying two powers, add the exponents, we have power of a power rule happening, so we're going to do that first. Remember BEDMAS? It works for exponents too, so you do multiplying before adding exponents. Okay, so that's going to be, I don't know what I was about to write there, 2 to the 4x. And now the rule is we add the exponents. Please don't write 7x, okay? 3 plus 4x. You can't really add those together. So you're going to write it simply as that, 3 plus 4x. Or you could write 4x plus 3. Okay, but don't put them together. They're not like terms. All right, next one. I was going to say go ahead and do this one, but now that I'm looking at it, that would be mean, right? Do all the easy ones and then let you guys do the hard ones. Okay, you can try them if you want. If you want to pause your video and then check back, that would be cool. All right, so let's see, base 2. Well, 512, okay. If you get to know these really well, 512 is base 2, and you would change that to 2 to the 9. How do you know that? Well, you probably don't have these memorized like I do, but you can try them on the calculator, like 2 to the 5. What is that? 2 to the 6. Oh, I need to go bigger. 2 to the 12. Oh, I'm way too big, right? Drop back down. Okay, but I know that 2 to the 10 is 1024, and 512 is half of that, so that's why it was 2 to the 9. Anyways, I go on, don't I? Okay, so 3x is up there. Now we multiply the exponents, power of power. So we have 2 to the, holy cow, 27x. All right, now we're not quite to base 2. I know you're thinking that we're done this question, but we're really not. We have to, it's 1 over 2 to the 27x. We have to write this as 2 to some exponent. Well, we're kind of unsimplifying it, right? We're going to move this 2 to the 27x back up to the top. And when we do that, the exponent goes negative. Just like from before, when we were trying to make it a positive exponent, so we'd move it down. Same idea. There we go. That's our final answer. All right. Oh, fractions. Yay. Okay, you're not saying yay. That's fine. Base 2/3. Okay, let's compare. 16, 2. I bet you 16 could be 2 to the something. 3, 81. Again, 81 is 3 to the something. So let's work with that. 16, if you know, is 2 to the 4. And I bet you anything, 81 is going to be 3 to the 4. Check it on your calculator, but pretty sure it is. Okay, and then we still have x plus 5 outside the brackets, our power outside. Put it in brackets, please. All right, now we have 2 to the 4 over 3 to the 4. What do we do with that? We're kind of unsimplifying, I guess. Remember that rule we had, x over y to the m, and how it applied to each thing inside, x to the m over y to the m? Well, we kind of have this right now, and we're going back to this. Both of these have an exponent of 4, so I can write that as 2 over 3 to the exponent of 4 on the outside. Of course, the x plus 5 is out there too. We can't forget about that. And then finally, we do power over power, so we multiply those. 2/3 to the 4x plus 20. And there we go, base 2/3. All right, good job. Let's look at the next page. Okay, so this is solving equations with rational exponents, so fractions in the exponent. I'm going to kind of skip this thing, but there's something I want to talk about down here, okay, with the examples. They give you this procedure, which I totally agree with. Raise both sides to the reciprocal power of the exponent and then simplify and solve for the variable. Let me give you an example. You've been doing this already. You just don't know that you've been doing this. If you have root x equals 3, okay, you guys naturally already go, oh, how do I get at the x? I would square both sides so that I can have just x, right? So that would be x equals 9. Okay, well, a square root is essentially x to the 1/2, right? So when you square both sides, what you're doing is you're multiplying the exponent by the reciprocal exponent, okay? Power of a power thing going on. And whatever you do to one side, of course, you do to the other side. So what happens here, if you multiply those exponents, 1 times 2 is 2. 2 times 1 on the bottom is 2. 2 over 2 is just equal to 1. So that's really just x to the 1 equals 3 squared. Okay, so you see how it works. You've been doing this already. We're just doing it with kind of uglier fractions. Okay, so here we go. X to the negative 4/3. We are going to do the exponent on both sides, and it's going to be the reciprocal. Yes, including the negative. Okay, because if you don't include the negative, we're going to end up with x to the negative 1, and we don't want that. Okay, so we multiply exponents. Negative times negative would be positive. 4 times 3, 12. 3 times 4, 12. 12 over 12 is 1. Okay, and then here we have 81 to the negative 3/4. Okay, so we will need to get a number for that, and we're going to try not to use the calculator here. So first of all, negative exponent. I'm going to rewrite that as 1 over 81 to the positive 3/4. That's our first step. Then, do you guys recognize we have a fraction exponent? Yes, yes, that's going to be a radical. Okay, so we go like, I don't know where this accent came from, sorry. Okay, so 81, and we have the 4th root, because the root is at the bottom of the plant, right? So we put the 4 here. 3 would be best done on the outside, because we don't want to do the 4th root of 81 cubed. All right, so let's simplify this. The 4th root of 81, I think we did this one already, didn't we? Is 3, and then we're cubing it still. So that's going to equal 1 over 27. Good. All right, one more example and we are finished this lesson. All right, okay, let's look at this. We want to solve for x. It's stuck inside brackets, but it has this ugly exponent. So let's get rid of the ugly exponent by doing an uglier exponent. Okay, so 2/3 on both sides. So on this side, that'll go to equal 1, and we'll be left with just 3x minus 5. Okay, on this side, we have 27 to the 2/3. Well, let's figure out what that equals first. So that would be the cube root, because the bottom number is what root it is, 27 and then we'll square that after we figure that. So cube root of 27, what number cubed gives us 27? That would be 3. And then we square that, and we would get 9. So back to here, that would be 9. Okay, so yes, you can do these on the calculator, but it will be so much faster if you do it in your head, if you're capable. Okay, if you have to, go to the calculator, but those of you destined for Math 31, please try to do these in your head, okay? All right, add 5 to both sides. So we would have 14, and then finally isolate x by dividing by 3. So 14 over 3. Woohoo! We got an answer. We got an answer. And this one was x equals 1 over 27. Okay, well, good job, you guys. All right, we'll look at lesson 2, possibly 3 for tomorrow, and hopefully the assignment goes well. All right, we'll see you then. Bye.